Hey guys, so here's a video on 3.2D1, and so what we're going to see now is we're going to see different kind of functions that are not just lines and parabolas, okay? There are going to be maybe of degree 5 or degree 6, meaning that the highest exponent you're going to see in them is bigger than 2, and we're going to see what these guys actually look like. Okay, so the first concept that we must go over here is to see what it means for a function to be continuous. So a polynomial function, first of all, is anything that's like y equals, I don't know, x to the fourth plus 5x plus 6. So basically, they don't have denominators that have x's in them, or they don't have square roots, anything like that. They just look like regular polynomials. But what we know about all polynomial functions is that they're continuous. Now, you guys, when you get into calculus, even maybe pre-calculus, they're going to give you an actual mathematical definition of what continuous is. But for us, all I need you to know that what it means to be continuous, is that you can, which means you can draw the graph of your function without lifting your pencil. Okay, so basically, you guys, something like this would be a continuous function. Let's say I drew something like this, right? I drew that without lifting my pencil. Or you could do something like this. That is a continuous function. I drew that without lifting my pencil. Now, what would be an example of something that is not continuous? Let me draw that in red. So something like this. Let's say I decided to draw something like this. Stop, and then a little jump, and then go back, okay? So something like that, I had to actually lift my pencil to go from this point to this point. So it had a little jump in there, okay? So that's not continuous. Or maybe something like this, like a simple parabola that has a little hole in it. Okay, that's not continuous either, because right here at that hole, I have to like jump, lift my pencil to get over it to get to the other side. Okay, so these guys right here are not continuous. So everything that we're dealing with in this chapter is going to be continuous, so you're not going to have to worry about those weird jumps, okay? All right, so the first thing we look at when you're going to sketch a polynomial function is something called its end behavior, okay? So what is end behavior? This is basically what's happening on the left side and what's happening on the right side of the graph as x gets really, really big, okay? So to determine this, we're going to use something called the leading coefficient test, and you guys, this is super, super powerful, okay? So here's what the leading coefficient test says, okay? So what you're going to do is step number 1 is you're going to find the degree of your polynomial, and that is basically the highest exponent. And you're going to ask yourself, is that number even or is it odd? Okay, so let's kind of go through an example as we're doing the leading coefficient test, and then we'll look at some examples later. Okay, so let's say I have the equation or the function f of x equals 3x to the fifth plus 2x cubed minus 1. Okay, I have no idea what this graph looks like, but I can find out what the ends of the graph looks like. Okay, so look, step number 1 is to find the degree of the polynomial. So you guys, the degree of this polynomial is 5. Okay, how did I get that? It's the highest exponent. The highest exponent is 5. Okay, and then I'm going to ask myself once I find that, is it even or odd? Well, in this case, 5 is an odd number, so we're going to say this is odd. Okay, that's not hard, right? Okay, now we're going to look at the leading coefficient. Okay, what is the leading coefficient again? Well, that's the number in front of the variable with the highest exponent. So my leading coefficient here is a 3. Okay, so I'm going to write leading coefficient. I'll just write lead coef like that is 3. And once I find the leading coefficient, I'm going to ask myself, is it positive or negative? Well, you guys, in this case, my leading coefficient is a positive 3, so I'm going to say that it's going to be positive, okay? Then I'm going to put that together. I'm going to say, okay, well, I have odd and I have positive, and what does that mean? Okay, so the different combinations you can get here. Look, you can get even positive, okay, which means that your end behavior is going to be up, up. And I usually just like to draw 2 arrows like that. And you guys, I'll show you why that's true in a second, okay? Another combination you can get is even negative. This means that your end behavior is going to be down, down. Okay, if we have odd and positive, that means your end behavior is going to be down, up. And if you're odd and negative, that means that your end behavior is going to be up, down. Okay, now you guys look, in our case, in this example, what would the end behavior of it be? Well, we had odd positive, which case we're here, so that means that our end behavior would be down, up for this particular problem. Okay, now you might be thinking, Ms. Cruzy, like, how did you even know that? Okay, well, let's look at some like basic examples, right? Something that, like, the easiest polynomial that I can think of that has an even degree or an even exponent is a parabola, right? So you guys, if you look at, for example, y equals x squared, okay, look, I know that if this number in front is positive, that it's going to be happy. And look at that end behavior there. Look, it's up, up, just what we got there, right? But I also know that if the number in front of it is negative, I know it's going to be sad. It's going to be down, down. So notice we got down, down. And the easiest example of an odd polynomial, I always like to think of y equals x cubed. Okay, you guys remember y equals x cubed looks like this. Like we went over that, right? And look, the number in front, if it's positive, the end behavior, look, it's going down on the left, up on the right. So it's down, up, okay? If I change that around and did negative x cubed, well, now it's just going in the other direction. So now its end behavior is on the left, it's up, on the right, it's going down, which we have up, down. Okay, that's how I kind of remember it, so I don't have to keep remembering all these weird arrows. Okay, so let's look at some of these, okay? So to determine the end behavior of the following polynomials, check with a graphing calculator, okay? So hopefully tomorrow I can show you some graphing calculator stuff. Okay, so the end behavior, what do I want to look at? I want to look at two things. I want to look at the degree, and I want to look at the leading coefficient. I'll just call it the LC. So the degree is the highest exponent, which is 3. That number is odd. The leading coefficient is the number in front, which is a -1, and that's negative. So look what we have. We have odd, negative. So what does it mean when I'm odd and negative? So you guys look at this. Odd and negative translates to up, down. So all you would write on your homework is that this has an up, down end behavior. Kind of easy, right? Okay, let's look at B. Okay, how do I find end behavior? I look at the degree and I look at the leading coefficient. Okay, so the degree here is the highest exponent, which is 4. That number happens to be even. And then my leading coefficient is the number in front of that, x to the 4th, which is just a 1. And this guy happens to be positive. So this time I have even positive. I have no idea why I keep rewriting that. It's kind of silly. But if you look at even positive, okay, even positive, the end behavior there is up, up. So all you would do, why did I click that? You would just write up, up. Okay, why don't you try maybe C by yourself? Maybe pause the video and see if you can get it right. Okay, so let's see what you got. So the degree here is the highest exponent, which is a 5. The leading coefficient is the number in front, which is a 1. So 5 is an odd number. 1 is a positive number. So I have odd positive. Again, I don't know why I keep writing that, but odd positive, if you guys look here, odd positive is down, up. So this is going to be down, up. All right, and you guys, most of your homework is just doing that and like getting really good at that. Now, the next step when you're sketching the graph of a polynomial is to find its zeros. Now, you guys remember the 0 is where your graph crosses the x-axis, and this is super important. Remember, how do we find the zeros? Okay, and we did this yesterday, so you should hopefully remember this, okay? To find the zeros, you're going to set the function equal to 0 and solve for x. Now, it says solve by factoring, but you don't always have to factor, okay? Sometimes it's just really easy to solve it, okay? And you guys also notice something that I pointed out here, zeros, solutions, x-intercept, they all mean the same thing. And that's really important because sometimes they'll say zeros, sometimes they'll say solutions, sometimes they'll say x-intercepts. You need to know that those all mean the same thing. Okay, so let's go ahead and just practice finding zeros. And you guys, this is just review, but I just want to make sure that you get really good at finding this, okay? So look, if I want to find the zeros, I'm going to send my function equals to 0. So I'm going to have -2x to the 4th plus 2x squared equals 0. And then I'm going to factor the right-hand side. So look, this is just a GCF factoring. I can pull out a -2x squared, which leaves me with an x squared minus 1, okay? And then I can set each of those factors equal to 0. So check this out. On the first one, I'm going to have negative 2x squared equals 0. Here I'm going to have x squared minus 1 equals 0. So you guys, on this one, I can divide both sides by negative 2, giving me x squared equals 0. But if I take the square root of both sides, I'm going to get x equals, now technically it should say plus or minus 0, but that really doesn't make any sense because 0 is a neutral number. So we're going to say x equals just a plain old 0. But you guys, look. The degree that this came from, right? This came from an x squared, right? It came from something that was a squared. So we got the same answer twice. It's really x equals 0 and x equals 0. So what we're going to write here is we're going to write a little multiplicity of 2. That means that x equals 0 is actually an answer twice. Now, if you're like, well, that doesn't really make sense. Look at this. If I had x squared equals 0, I can rewrite that like this. X times x equals 0, right? Now I could set each of those guys equal to 0, giving me x equals 0 on the left, x equals 0 on the right. There's actually 2 answers for that. And it's actually important when you're graphing. So this time, I not only want you to find the 0, but you need to give me the multiplicity of each 0. Okay, let's look at x squared minus 1. Okay, so if I add 1 to both sides, that gives me x squared equals 1. If I take the square root, I'm going to get x equals plus or minus 1. So that again gave me 2 solutions, but it gave me 2 distinct solutions. So it gave me x equals 1 and then x equals negative 1. So I got those 2 solutions, but these guys each have a multiplicity of 1, in which case you don't have to write that if they only occur one time. So these would be your zeros. And notice you should have 4 total. Look, you have 2 zeros, 1, 1, and 1, negative 1, which is a total of 4 answers. All right? Okay, let's try B. So again, we're going to set f of x equal to 0. Okay, I'm going to take out a GCF here. If you notice, an x squared goes into all of those. So you'll have x squared minus x minus 20. And then I'm just going to use the big X factoring on that guy in the parentheses. So I need 2 numbers that give me negative 20 and negative 1 on the bottom. So that looks like it's going to be a negative 5 and a 4. So this is going to factor to x minus 5 times x plus 4. Okay, now setting each of these factors equal to 0. Okay, you guys notice this x squared equals 0. That's just a repeat of what we did here, right? Look at that, the same thing, right? So this is again going to give me x equals 0, but with a multiplicity of 2. Okay, it's like really ugly, but it's okay. If I set x minus 5 equals 0, I'm going to get x equals 5. There's just one answer there. If I set x plus 4 equal to 0, I'm going to get x equals negative 4. So you guys, my final answers should be x equals 0 mult 2, x equals 5, and x equals negative 4. Notice I have 4 answers total. Okay, it should always add up. Okay, let's look at part C. Okay, again, set f of x equal to 0. So I have x to the 5th plus x cubed minus 6x. I'm going to pull out an x, leaving me with an x to the 4th plus x squared minus 6. Okay, and then you guys, I'm going to go ahead and try to factor this guy here, doing the big X. And I'd be thinking, how do you do that? Okay, so I have 2 numbers that multiply to give me negative 6 and add to give me 1. That's going to be 3 and negative 2, right? So this will factor to x squared plus 3 and x squared minus 2. Okay, so how am I going to get that? Okay, so if I set each of these factors equal to 0, okay, for the first one, I'm going to get x equals 0. There's only one answer there, so that's just a mult 1, so you can leave it like that. This guy is a little bit weird, because if I subtract 3 from both sides, I'm going to get x squared equals negative 3. And you guys, what happens when I take the square root of a negative number? This is imaginary. Okay, this means that it's not giving me any real zeros, so that one is not going to count in this case. Now, it's an imaginary 0, but on a graph, it's not going to cross the x-axis, okay? So we can just leave that one. And then this guy, x squared minus 2 equals 0. If I add 2 to both sides, I get x squared equals 2. Take the square root of both, so I'm going to get x equals plus or minus the square root of 2. So you guys, again, 2 distinct answers here, a radical 2 and a negative radical 2. Okay, so both of them just have one multiplicity there, no multiplicities 2. So the only place where this is going to cross the x-axis is at 0, radical 2, and negative radical 2. Okay, let's do one more. Again, set f of x equal to 0. Okay, and then you guys remember, if there's 4 terms, we're going to group this, right? So I want to group the first 2 terms and the last 2 terms. so here, let me move this 0 down a little bit. It's really going to bug me. Okay, so I can, out of the first two terms, I can pull out an x squared, leaving me with an x minus 4. Out of the last two terms, I can pull out a negative 25, leaving me with, again, an x minus 4. And you guys remember, when you're grouping, the stuff that's left in the parentheses should be exactly the same. If it's not, you did something wrong. Or it's not factorable by grouping. Okay, so if I pull out that x minus 4 out of both of them, I'm going to be left with x squared minus 25. And if you want to go even further with this, like, you can totally break this guy down. That's just a difference of 2 squares, x minus 5, x plus 5. Okay, I said that backwards. Okay, now setting each of these guys equal to 0, this is going to give you x equals 5. That's just one answer. This is going to give you x equals negative 5. And look at that. Oh, wait. I wrote this down wrong. I'm an idiot. Sorry. This is a 4. I'm like, it's a multiplicity. I got all excited. So it's x equals 4, negative 5, and 5. And you guys, all of these have multiplicities of 1. They're just one unique answer. They don't repeat themselves. So you really here have 3 distinct answers, and that kind of matches up to that. All right. So you guys, before we get to graphing these, it's super important that you know how to find these zeros, because that's going to be like probably the biggest math thing that you have to do when you're graphing it. All right, so practice your even and odd and your end behavior, and then practice finding your zeros, and then we're going to put it all together and actually make a graph. All right, hope you enjoyed that.